A, we love math, A, we love math, A. Every time we divide, we already know the path, A. Then we multiply, all we gotta do is roll the die, A.
Hey math lovers, let's go over lesson 1.4, solving quadratic equations by factoring. Just to give you an idea, remember, solving quadratic equations, just give you a quick picture on the coordinate plane. We're trying to basically just solve for these two blue dots. That's what solving means, right? We're solving for the roots, x-intercepts, the solutions. And we're going to do this specifically by a method called factoring. Standards for mathematical content, we're going to solve quadratic equations with real coefficients that have complex solutions. Extend polynomial identities to complex numbers. Right? Don't forget those pirates. Aye! And use the process of factoring and completing the square in a quadratic function to show zeros. Remember, zeros is another way of saying those blue dots. And extreme values. And symmetry of the graph, and interpret these numbers in context. Well, how can you meet these standards? I can use factoring to solve quadratic equations and real-world problems that have real and complex solutions. Okay, let's go on to this next part called Standards of Mathematical Practice. How can I use these practices? Well, mathematical practice number 1, make sense of problems and persevere in solving them. I can solve quadratic equations by factoring and then check my answers by using a different method. Mathematical practice number 7, look for and make use of structure. I can look for patterns and discern a structure for factoring quadratic equations. All right, what is our learning targets here? In this lesson, all right, learning targets in this lesson, students will be able to learn how to solve quadratic equations by factoring. By the end of this lesson, students will be able to answer the following questions. What methods are used to factor trinomials? Number 2, how can quadratic equations be solved by factoring? And number 3, what's special? What special products can help solve quadratic equations by factoring? All right, let's see what you know. Let's see if you can factor. I have 5 questions over here in the warm-up. Go ahead and try those, and then go ahead and press play if you need some help or you're ready to check your answers. All right, so before I go over the warm-up, it might just be helpful. How do you factor quadratic trinomials? Here are some steps. So step number 1, set equal to 0. You basically want everything on one side of the equation. Number 2, I want you to look for the greatest, I can't spell greatest common factor. And there might not be a greatest common factor or GCF, but what it does, it makes our quadratics or a polynomial smaller. Number 3, put it in standard form, which we learned last lesson in lesson 1.2, which is ax squared plus bx plus c. Step number 4, identify the a, b, and c. Number 5, the x. You're going to have a times c on the top and b at the bottom. Number 6, I'll put over here, you're going to do the box. And the box looks like this. And what you put inside the box I'll just use the above one as a help. You're going to put ax squared always in this part right there. Something I forgot is that you're going to find a number and you're going to get in purple here the product. Product means to multiply those two numbers to get a times c. And those same two numbers, you will get the sum, or you add them together to get b value. Okay. Once you do that, you will take these two values and put them here always. So I'm just going to write something x, something x. And then you're always going to put your c value here in the bottom right. So if you go back to standard form, basically what you're doing there is you're taking these and putting them in here, and that's how you're going to fill out your box. And then number 7, binomials. And you get the binomials that are on the outside here. Your answer will look like this. Okay? All right. So this is called the area model of factoring using the X box method. You'll notice there's an X and there's a box. Okay. Question number 1. Set it equal to 0. You'll notice there's no equal sign, and basically everything is on one side of the equation, so you're done. The next thing is you're going to find the greatest common factor. You'll notice that this is m times n, and this is m times n times w. Now, you'll notice that they have a what in common? An m, and they also have an n in common. So we call this to factor out. I'm going to have this m and this n on the outside. Now pay attention. In the inside, up here, there's nothing left, so I'm going to put a 1 here. So that would be 1 plus, there's the plus, and then this one is not, is left. So here in this problem, all I had to do was just the greatest common factor. All right, to check my answer, you can do something called distribute. So you can take this, mn times 1 will give you mn. Mn times w will give you mnw. So all I had to do in this problem was factor out the GCF. Okay? I want you to notice something. This method, for question number 1, does not apply to how do you factor quadratic trinomials. Trinomials has 3 spots, 1, 2, 3. It is also quadratic, so it has a power of 2. You'll notice that this question here had no power of 2. Okay, let's look at number 2. This one is a perfect example. We're going to set it equal to 0. So it's already on one side of the equation. You can just put it equal to 0. And here they're just asking us to solve. I'll tell you about. They're asking just to factor. Okay. They have nothing in common, right? X squared, 4x, and negative 5. It's already in standard form, but what I'm going to do is identify the A, B, and C. We've done that before, right? So we can say A is 1, B is 4, and C is negative 5. Remember, that comes from standard form. And the coefficients A, B, and C never have an X on it. Okay, so we've done that. Now we're going to have to do this box method, okay? The X method first. So A times C goes here, and B goes there. So A times C is -5. My B value is just 4. All right, so now I need to think of two numbers. Those same two numbers, when I multiply them, they are -5, but when they add together, their sum is 4. So let's say I pick 5 and 1. 5 times 1 is +5, so one of these has to be negative. So I'm thinking that this is -1. 5 times -1 is -5, but 5 plus -1 or 5 minus 1 is 4. Okay, next thing I'm going to do now is put it into my box. You have it previously, it did not save, somehow my iPad crashed. Thank you very much, iPad. And let's go ahead and put it here. Okay, so let's use different colors. You will always put this term here in the front, always. So not ax squared, but in this case it'll be just x squared, okay? This bx term is these two, so 5, and we're going to add an x, and -1x, okay? And you'll notice it goes back up to the original one up here. 5x minus 1x gives you 4x. And then the last thing is -5 will always go out here. Okay, what I'm going to do here is I'm just going to take out the greatest common factor. So what do they both have in common? They both have an x in common. Let's go down. 5x and -5 have something in common. That is a 5. If I go up at the top here, I'm trying to think of something of the column up and down, x squared and 5x. What do they have in common? They have an x in common, and -1x and -5 have a -1 in common. And the cool thing about this is you can use this to actually check your answers. X times x equals x squared. X times -1 equals -1x. X times 5 gives you 5x, and 5 times -1 gives you -5. Okay, so my two answers are actually out here. Whoa, too bright. Are out here on the outside. So when you factor that, you will get x minus 1 and x plus 5. Now the order does not matter. So we just factored x squared plus 4x minus 5. Now I want to open this up. If you were taught a different method, totally use that different method. Guess and check, hockey sticks, tic-tac-toe. There are a bunch of them, but I'm just showing you one, and if you're going to use my method, keep using it. Okay, question number 3, we're going to do the same thing. Ax squared plus bx plus c. So a is 2, b is 9, c is 4. I'm going to put it into my x and my box. Okay, so I have a times c here. So a times c, so 2 times 4 is 8. My b value will always go down here, so that is 9. Two numbers that multiply to be 8, you can think of them as 8 times 1 and 4 times 2. And my two numbers are going to be 8 and 1. 8 times 1 gives me 8, and then if I add those two numbers together, they give me 9. Okay, let's go ahead and put in these now. This term will always go in the top left. The red ones are really this. See it? So 8x and 1x. And do you remember what always goes in the bottom there? Yeah, this one, the plus 4. Okay, let's take out the greatest common factor now of each row and column. This one has an x. Going down, this one has a 4. The column has a 2x, and this one has a 1. So these are going to be my answers right here. Just put it up here. 2x squared plus 9x plus 4 is the same thing as 2x plus 1 and x plus 4. And we'll go over and practice more details later of each of these. Question number 4. This one is missing a middle term, so I'm going to add 4x squared plus 0x minus 25. That means my a value is 4, my b value is 0, and c is negative 25. Now the reason why I added again as 0 is because you'll notice that negative 25 is not the b value. The b value has an x attached to it, but this one does not, so you can have a 0x there. Alright, let's do our x and our box. Okay, a times c, so 4 times negative 25 is negative 100. My b value is, we'll always go down here, is 0. Okay, two numbers that multiplied would be 100 or negative 100. So you can put up the factors up here. All right, which one, if I add them, will be 0? Now, to get 0, you're going to have one positive, one negative. Let's check. Positive 10 times negative 10 gives you negative 100. Positive 10 plus a negative 10 gives you 0. So that is the correct answer. Okay, the a always goes up here, so 4x squared. The red one is our b value. So you'll notice that 10x and negative 10x is equal to 0x. And negative 25 is my c value, always goes in the bottom right, always. Okay, here now, we're just going to take out the greatest common factor of each row. A row goes left and right, so this would be 2x. Down here, this would be a 5. In the column, it would be 2x, and this one would be a negative 5. Let's double check our answers. 2x times 2x gives me 4x squared. 2x times negative 5 gives me negative 10x. 2x times 5 gives me 10x. And 5 times negative 5 gives me negative 25. So these are my answers right here. I'll put it right up here. Why? Because you factor 4x squared minus 25, you'll get 2x minus 5, and 2x plus 5 is our answer. And the last one, a is 25, b is negative 30, and c is 9. Let's do our x in our box. Okay, a times c is 5 extra 4, 225. So a times c. My b value always goes in the bottom here, negative 30. So I'm going to write out all the factors of 225. So this is a great strategy when the numbers are big, you can't see it. Okay. How about, how many 25s in 2,025 cents? So 4, 8, 9. 15, I believe. 15 squared. Oh, I think I got a winner. But how do you add them to get negative 30? Well, that means they're both negative. Negative 15 times negative 15 is 225. And negative 15 plus negative 15 is negative 30. Okay, so that means my A value always goes in the top left. Always. My B term is now split between these two, right? Negative 15x and negative 15x. Basically, if for those who are more advanced or know how this works, this is actually factoring by grouping, the box method. Factoring by grouping. And this last one here always goes on the bottom. All right, let's go ahead and take out our greatest common factor in this row. That would be 5x. This one's got to be negative 3. 5x, and what do you think? Negative 3. Now, if you think about this, let's double check. 5x times 5x is 25x squared. 5x times negative 3 is negative 15x. Negative 3 times 5x is negative 15x, and negative 3 times negative 3 is positive 9. Okay, so if I get these answers, 5x minus 3 and 5x minus 3, well, pretty much they're the same. And if they're the same, you basically have how many of those? You have 2. So we can say 5x minus 3 squared, okay? And that's the warm-up. Sorry, I didn't say question number 1, but you could just rewind there. All right, let's talk about our vocabulary words here. In our vocab, a form of quadratic equation, 0 equals a times x minus p, that one should say x minus q, where a is not equal to 0, in which p and q are x-intercepts of the graph of the related function. This is called factored form. Factored form. And I'm going to put a big star by this. I don't really use stars, but we've only had another form. The other form that we've had so far is standard form. So now we have 2 of them, standard form of quadratics and the factored form of quadratics. I also want to point out that it says P and Q are x-intercepts of the graph. Oh, I did save it. That's what I was talking about. There's my x-intercepts right there. Okay? That's all we're doing. All is finding those 2 dots. Crazy, huh? Okay. A binomial. So what is a binomial? A binomial is basically a parentheses, has something like this, x minus something. Up here you see 2 binomials. A binomial in which first and last terms are perfect squares. Okay, this is called the difference of squares. And it basically looks like this. So I have 2 binomials, 2 sets of binomials, and it's kind of like, not conjugates, but the same idea as conjugates. One is a positive, and then one is a negative. Okay, those are called difference of squares. If you want to see a visual why, these are called algebra tiles. So if I do this red box, x times x is x squared, and then if you did okay, say the green ones are negative 1s, so that basically represents negative 3. And then if you did positives over here, I'm sorry, these are positive 1x's, and this is negative 1x. This is negative 3x, so a positive 3x and a negative 3x will cancel, so that's gone. And basically what we're doing is then we're finding out this is like a square. I don't know if that makes sense. But this is the conceptual of factoring. You'll notice it's kind of like the outside of the box, and x plus 3, x minus 3. No, those are supposed to be just positive 1s. And everything's disappearing, but hopefully you get the idea. Okay, what's the squares of binomial? this one, the answer is perfect square trinomials. And that's basically, that was warm-up number 5. Warm-up number 5. Difference of squares was the plus and ones minus. That was warm-up number 4. And all of those were factored form, questions 2 to 5. Okay? All right, let's move on now to the first one. All right, 1.41, let's factor a trinomial, but when your c value is equal to 0. Let's go ahead, directions say complete this, do this with me. I'm going to show you how to do this problem in 2 ways. So let's call this number 1, the first way. Okay, I have a quadratic trinomial here. The first thing I'm going to do is I'm going to go ahead and subtract this x. And it has a 1 in front, right? So these right here are like terms. And you'll get 12x squared minus 3x equals 0. Okay, in this method, now that you have it set equal to 0, the next thing I'm going to do is see if I can find a greatest common factor. Okay. In blue, this is 3 times 4 times x. These are called the prime factorization of 12x squared. And over here in, let's do purple, negative 3x is going to be, you can leave the negative sign or do a plus negative 1, but I'm just going to do 3 times x. Well, those should not, equal sign should be, they already have an equal to 0. Okay, what do I have in common here? And hopefully you can see my color coding. I have a 3 in common. And I have an x in common, the light blue. Okay, what do I not have underlined in red or light blue? That's a 4x. And there's nothing left in there. When there's nothing left, it's always a 1. Why? Because I need to write something there. This is my answer, 3x times quantity 4x minus 1. How does that work? Well, if you do something called distributing, which means there's a multiplication, you could do 3x times 4x. That will give you a 12x squared. 3x times negative 1 gives me a negative 3x. Okay, I realize that we are not done because this one's asking us to, I should put a period there. Solve each equation by factoring. Check your solution. Okay, so we've factored it. Now I need to solve it. Don't have the equal sign. I already have ones at equal sign. Okay, so if I said that square times a triangle equals 0, that says that basically the square has to be equal to 0 or the triangle has to be equal to 0. I call this the 0 product rule. Product means multiply to be 0. So you're going to set this one equal to 0 and this one equal to 0. So let's just note this. This is my factored form, or basically all we're doing here is factoring, and then everything below here, whoops, we are doing something called solving. Solving basically means we're going to have x equals. Okay? Alright, so let's go ahead and solve this. I'm going to divide by 3 here. X is equal to 0. Remember, when you're solving, you're going to do PEMDAS backwards. Let me write that. This is my cool little trick. I hope you are simplifying. And then when you're going up here, you're solving. What does that mean? It tells you that if you're solving, do not divide by 4. do not divide first. And divide by 4, you're going to get x equals 1/4. Okay, this is what it means to solve. It says x equals. Remember the big idea here? Just show it to you. This is 0. Let's say this is 1/4. This one was 0, and basically that's where the graph goes through. Does that make sense why we're doing that? Okay. Go ahead and try 2 of these problems over here. Let me show you guys a second one, because this method that I just showed you did not involve the Xbox method, and I just want to show you that the Xbox method works. Okay, so basically we had it down to the second line over here, 12x squared minus 3x. Now if you think about it, you have a plus 0. Right? You can always add a 0. Nothing has changed if you add a 0 there. And if you do standard form, you'll have a is 12, b is -3, and c is 0. And then what I can do with that is just use my Xbox method of factoring. And I'm trying to show you guys 2 methods, and you just pick one that makes sense to you and then keep doing that, okay? Okay, so I have a times c is 0, and my b value is -3. What 2 numbers multiply to be 0 but added to be -3? 0 and -3. This splits my middle term, so you need to add an x. They always go on the bottom left and top right. Here is my a term, so 12x squared always goes there, and our plus 0. 3x is our greatest common factor for that row. 0 is greatest common factor. 0x, actually that's wrong. And I'm thinking ahead to check my answer, 4x, and -1. And I want you to notice, let's see if I can highlight this in this cool blue, 3x, it's too dark. 3x is the same thing as this one. And 4x minus 1 is the same as this one. So I'm trying to show to you that you can get the same answer. And what does it mean to check your answer? You could put in 0 in here. Let's put in a number, x equals 0. You could put it here, here, and here. So 0 squared is 0, 0 times 12 is 0, 0 minus -2 times 0 is 0, so 0 equals 0. That works. You can also do 1/4 to check your answer. 1/4 squared is 1/16, 12/16. 1/4 is, I lost track. 12/16. 1/4 is -8/16. So -8, 4/16, which is 1/4, and 1/4 is equal to 0.4. Okay, so that's how you would check your answer. Go ahead and complete 2 of these over here, and then press play if you want to check your answer. I'm just going to go ahead and solve this by using the first method, number 1 in blue there that I showed you, because I think that's the easiest one. It's already set equal to 0. I'm going to take out my greatest common factor, and that is 2x. Why is it 2x? Well, if 2x times something equals 6x squared. That would be 3x. 2x times something equals -2x. Well, that would have to be -1. Those are already factored, and now I can just set those equal to 0. 2x equals 0. X is equal to 0. Pretty fast, right? This one, you set this binomial equal to 0. Remember, use PEMDAS backwards. So we're going to add 1 and then divide lastly. So x equals 1/3. Okay, this one, number 2, gotta be careful. Do not divide by x on both sides. You'll say that x equals 7. I want to show you why x equals 7 is not complete. So the first thing I'm going to do, I like to draw a line down my equal sign. I'm going to subtract 7x. I always want a to be positive 1. I want the a value to always be positive, never negative. Okay, so here I'm going to factor out, so they both have an x in common. So I'm going to have x minus 7. Remember, you can always distribute to check your answer there. And then I'm just going to set both those equal to 0. X equals 0 is actually a solution, right? X equals is how you solve. And this one, x equals 7 is my answer. Okay, those are my 2 solutions. And question number 3. Add 25x. I'm going to take out my greatest common factor. Remember, a strategy of doing that, you can break them up into your factors. What do they have in common? They have a 5. Each of them both have, in the parentheses, both a 5 and an x. Do you see that? So I wrote 5x. That would be 4x, and this one is not highlighted, plus 5. And then we're going to apply the zero product rule, which basically means we're going to set both of those equal to 0. Divided by 5, you're going to get x equals 0. And this one, 4x plus 5 equals 0. So again, you have to use the PEMDAS backwards, so that would be 4x equals negative 5, and then divided by 4, x equals negative 5/4. And those are my answers, and you can check your answer by putting it in there. If I put in 0 here, 0 squared is 0, 0 times 20 is 0, negative 25 times 0 is 0. 0 equals 0. Negative 5/4, ooh, that would be fun. Negative 5/4 times negative 5/4 is 25 over 16. I'm going to forget 25 over 16 times 20, and negative 25 times negative 5/4. Are these equal? Okay, so 20 is 4 times 5. 16 is 4 times 4. Let's see what happens. Okay, on this side, my 4's cancel, so I'm left with 125 over 4. Negative times negative is positive. Multiply across, you get 125 over 4. So that works. That was checking my answer. Okay, let's move on to 1.42. Factor trinomial when the a is equal to 1. Alright, 1.42, factor a trinomial when a is equal to, that should say 1. Alright, directions complete this do this with me problem, and then for questions 4 to 6, you do 2, skip one of those. Okay, it tells us to solve x squared minus 6x minus 9 equals 18 by factoring, and check your answer. Okay, some students will be tempted to just factor right there in the yellow box. And that would be a mistake because question, is that equal to 0? It is not. So x squared minus 6x minus 9 equals 18. I'm going to draw this line down my equal sign. And then I'm going to subtract 18. Put that underneath the like terms. X squared minus 6x, that would be negative 27 equals 0. Okay, my A is 1, B is negative 6, and C is negative 27. I'm going to do my X box over here. X, the box. Okay, A times C is 1 times negative 27, which is negative 27. My B value will be negative 6. Let's think about all the products of 27. You can write them out. I like to do this. 9 times 3. And I think we have a winner, right? Okay, how do I get that to be negative 6? Well, if I add negative 9 plus 3 will give me a negative 6. And those two numbers, negative 9 times 3, gives me a negative 27. So, let's review how to do that. We thought of these two same numbers in red. They have to be the product or multiply. And those same two numbers have to have a sum or add. Okay. This term will always go in the top left. Always. This red term, negative 6x, is really split in between negative 9x and 3x. They will always go in the bottom left and top right of the box. Always. And then the last one is negative 27. Your C value will always go in the bottom right. Always. Now I'm going to take out the greatest common factor of a row and a column. In this row it is x. This one is negative 9. In the column, x squared and negative 9x, that would be a x. And this one, a little bit tricky, is going to be a 3. Let's double check. X times x gives me x squared. X times 3 gives me 3x. Negative 9 times x gives me negative 9x. And negative 9 times 3 gives me negative 27. So this gives me x minus 9 and x plus 3 equals 0. Basically what we've done so far is, I'll just try to make this super obvious. Make sure I have it kind of small. Everything in green here that we've done so far, this is called factoring. Factoring, okay? Now we're not done yet because we need to solve. So the next thing I'm going to do to solve is do the zero product rule, which means set it equal to 0. If I solve over here, I get x equals 9. And over here I subtract 3, x equals negative 3. And remember the big idea here. If you're actually graphing this, this is 9. This one is negative 3. And my graph would look something like this. Okay? And I can tell you a bunch of more stuff. I know that A value opens up, and there is negative 27, the y-intercept. And now it's going to tell us to check your answer. So if you did the original problem, and we put in negative 3, so negative 3 squared minus 6 times negative 3 minus 9, does that equal 18? So that is 9 minus 18 minus 9. And that is true because that becomes positive 18, and those equal 0. Let me do the same thing for x equals 9. 9 squared minus 6 times 9 minus 9, does that equal 18? So that would be 81 minus 54 minus 9, and this will be 27 minus 9, and that will equal 18. So blue and green there, and that's how you check your answer. Go ahead and pick 2 of these to do, and then press play to do that with me step by step, or to check your answer. Oh, so sorry. The big idea here is that all of this work here, just doing blue. This was something called solving. And then this, I should erase this right there. This one in red this one is called checking your answer. Okay, so hopefully you can kind of see it broken down into kind of 3 big things you need to do. All right, question number 4. Let's go ahead and solve this. Some of you who are getting good at this might recognize there is some tricks, but I won't tell you the tricks, because tricks are for kids. That math phrase got me a job. Okay, so A is 1, right? There's a 1 right there. B is also 1, and C is negative 30. So A times C would be negative 30. My B value is 1. And the factors of 30 are 30 and 1, 15 and 2, 10 and 3, 6 and 5. Do any of those kind of match, right? The difference of those. Did you notice I put the bigger number on the left and the smaller number on the right? Well, that one matches. How does that work? Well, 6 times 5, one of those has to be negative, and I believe it's going to be this one. Now, why did I choose negative 5? Because 6 times negative 5 is negative 30. Well, 6 plus negative 5, or 6 minus 5, is a positive 1. All right, let's go ahead and fill this out. So this one will always go in the top left. The 1x is split between these, so 6x and negative 5x. And then the 30 there, negative 30, will always, or the C value will always go in the bottom right. Let's take the greatest common factor of the top row. This is an x. This one's going to be a 6. This is going to be a positive 6, right? Column, going up and down, this is going to be an x. And this is going to be a negative 5. Remember, it doesn't matter which order you write these. What does matter is the math operations. So we've just factored x plus 6, x minus 5. I'm going to set each of those equal to 0. And I get x equals negative 6. And then x minus 5. Add 5. And you get x equals 5. How do I know I solved these? It's because it says x equals. It solves the equation, so let's go ahead and check our answer. Negative 6 squared plus negative 6 minus 30. Does this equal 0? So 36 minus 6 minus 30. And that becomes 30 minus 30, which is 0. Let's try 5. 5 squared plus 5 minus 30, so that is 25 plus 5, which is 30, and 30 minus 30 equals 0. So that checks, that is true. Okay? Let's go on to number 5. Do you see any greatest common factor there? Well, is it set equal to 0? Yes, it is. Is it greatest common factor? The first two have an x in common, but the 33 does not. Okay? So we just need it's a trinomial because it has x squared. It has a b value and a c value. Let's go ahead and do our x. A times c, this gives me 33. My b value, which is 14. Let's write out the factors here. 33 and 1. How about 11 times 3? Oh, look at that. Does that work? It does. Let's double check. 11 times 3 gives me 33. And 11 plus 3 gives me 14. So that works. Yay, hooray. Okay, x squared, that one, the a value will always go on the top left. Always. The 14x is really 11x and 3x. So 11x and 3x. Those will always go on the bottom left, top right. And then our last one, the c value, will always go on the bottom right. Let's go ahead and take out the GCF in the top row. That'll give me an x. Bottom row will give me an 11. The top column here, they have an x in common. And then this one has a 3 in common. Remember, you can always check your answer. X times x gives me x squared. X times 3 gives me 3x. X times 11 is 11x. 11 times 3 gives me 33. So when I factor this, this will give me x plus 3, x plus 11. Let's go ahead and set each of these equal to 0 now. 0 product rule. Subtract 3, this will give me x equals negative 3. That's where it crosses the x-axis, the x-intercept. And over here, we just subtract 11. You'll get x equals negative 11 is your answer. Let's quickly double check our answer here. Negative 11 squared plus 14 times 11 plus 33. And does that equal 0? 121. Getting my calculator out here. 14 times 11. So 121 up, this is negative, so this one will be negative. So minus 154 plus 33 equals 0. Excuse me, did you hear that? It's time for dinner. Okay, let's check our answer by putting in negative 3 into the original equation. That's what I'm doing here. Negative 3 squared plus 14 times negative 3 plus 33 equals 0. 9 minus 142 plus 33. Negative 33 plus 33 equals 0. Remember the big visual. Blue is negative 3. And then the green, negative 11. And then my graph. And that kind of makes sense. I want to point out one extra one here. The c value is your y-intercept, right? Okay. And the last one here, number 6. Okay, so the temptation here is to try to go ahead and solve this, but question number 1, is it set equal to 0? It is not. So Let's go ahead and move that 10 over. X squared minus 3x minus 10 equals 0. You know, your a value is going to be 1. Negative 3, C, b value, and C negative 10. And hopefully you're getting better at these. Some of you can do them in your head. Some of you guys know some shortcuts. I'm not going to tell you a shortcut. Maybe I will. One day, trick or treat. A times C is negative 10. B value is negative 3. Remember, if you write all these out, sometimes it helps. And this one's going to be negative. Let's double check those. Negative 5 times 2 is negative 10. And negative 5 plus 2 gives me negative 3. So x squared always goes in the top left. Negative 3x is negative 5x plus 2x. Those will always go in the bottom left, top right. And then your C value, negative 10, always goes in the bottom right. Let's go ahead and factor this out. Remember, if you broke them out into factors, this would be x and x, and this would be 2 and x. So they have an x in common. This one down below is negative 5 times x. This is like negative 5 times 2 times x, so that would be a negative 5. Going this direction, they have an x in common. And going in the other direction, they have a 2, not an x over here. So that would just be plus 2. And again, you can always multiply to double check those work. Okay, we just factored using the Xbox method. Let's go ahead and solve these. Set them equal to 0. X equals 5. This one, x plus 2 equals 0. X equals negative 2. And that's it. Just double check your answers. Let's put in negative 2 squared minus 3 times negative 2 equals 10. That'll be 4 plus 6 equals 10, and that is true. 5 squared minus 3 times 5, does that equal 10? 25 minus 15 equals 10 is true. All right. Let's move on now to 1.44. All right, we are skipping. Notice we're intentionally skipping example 3, or what I would have called 1.43. All right, let's move on to factoring a trinomial when a is greater than 0. Go ahead and complete or do this with me. What do we got? In this example, they're going to tell us to do the same thing. Solve by factoring and check answer. (3x squared plus 5x plus 15 equals 17. Put your finger or circle the mistake you think students will make. I think they will forget about the 17 and they'll try to factor the left side. Okay, so let's go ahead and do this correctly. We're going to subtract 17. And this will give us 3x squared plus 5x minus 2 equals 0. Okay, from here now we can do our Xbox method. A times C, so this is A, B, C. So A times C is -6. My B value is 5. What are my two numbers? I think they're going to be 3 and 2. No. It's going to be 6 and 1. 6 times a -1 is -6, and 6 plus -1 equals +5. So the 5x is 6x and -1x. This will always go right here. Always. 3x squared, top left, always, and -2 in the bottom right. Always. Whoops. All right, let's factor out the top row here. 3x squared and -1x have a x in common. 3x squared and 6x have a 3x in common. 6x and a -2 have a 2 in common. And then -1x and -2 have -1 in common. Let's double check our answer by multiplying. X times 3x is 3x squared. 2 times 3x is 6x. X times -1 is -1x. And 2 times -1 is -2. That matches. So I have 3x minus 1 and x plus 2. Well, I forgot to write the step above it, which just says that these binomials are answers to factoring. Okay, let's go ahead and solve this. Remember, do not divide. PEMDAS tells you to add first. And divided by 3 here. X equals 1/3. Subtract 2. X equals -2. And let's just check our answer. So let's do, you can do the original problem. Doesn't 3 times -2 squared plus 5 times -2 plus 15. Does this equal 17? 3 times 4 minus 10 plus 15. 12 minus 10. And 2 plus 15. Does equal 17. Let's go ahead and try x equals 1/3. Okay, 1/3 squared is 1/9. 5 times 1/3 is 5/3. Just multiply across here. See that? Okay, so this one is going to become 3/9. And an equivalent is 15/9. Oops, I was peeking ahead. So this will equal 18/9, and 18/9 is just 2. So 2 plus 15 equals 17. That does match. Okay, so that's how you factor with greater than, a is greater than 1. For questions 9 and 11, go ahead and do 2 of these. Go ahead and skip 1 of them. So already set equal to 0. Perfect. So there's my a value. C value is, so a times c is going to be -6. And b value is -1. What are my two numbers? 3 and 2. 3 times a negative 3 times positive 2 equals negative 6. Negative 3 plus 2 equals a negative 1. So this one will always be these two terms here, and that goes at the bottom left always, top right always. This blue term here, 2x squared, and the c value, negative 3. What does the top row have in common? 2x. Bottom row has a negative 3 in common. Top column here has x in common, and then this one has a plus 2. Let's double check our answer. 2x times x, 2x squared. Negative 3 times x is negative 3x. Negative 3 times 2 is negative 6, and 2x times 2 equals 2x. Not nice. All right, 2x minus 3. And the other one is x plus 2. Let's go ahead and solve that by setting both of these binomials equal to 0. And this one, again, PEMDAS backwards, so tells us to add or subtract first. And don't forget what we're doing here is x equals 3 halves, or 1.5. Green is negative 2. And basically we're getting a parabola here. And remember that c value being negative 3. That's your y-intercept. Okay, so you didn't need to do that, but I want to make sure conceptually you know what you're doing. And let's go ahead and try to check our answer. 2 times 3 halves squared minus 3 halves minus 3. Does that equal 0? So I'm going to square that first. So I get 9/4 times 2 minus 3 halves minus 3 equals 0. So this will become, you can multiply, or this 4 here is going to become 2 times 2. Why did I do that? So I can do something like this. I can cancel these 2, so I'm left with 9 halves. 9 halves. So 9 halves minus 3 halves minus 3. So I'm just going to subtract 9 minus 3, which is 6. 6 over 2. And 6 over 2 is 3, so 3 minus 3 is 0. That works. Okay, let's go ahead and check x equals negative 2. What is that thing? It's a parentheses. Okay, so negative 2 squared is, I'm using PEMDAS, that would be 4. Opposite of negative 2 is positive 2. This doesn't look good. I messed up, I can tell. Minus x minus 3. Negative 2. Negative 2 is 4. 2 times 4 is 8. That gives me 7. Do you see why I'm saying this is wrong? Oop. I can see it again. It is plus 1. Plus 1. And that's why you check your answer. I knew that. Okay, so this becomes 1. Subtract 1, you get negative 1. I knew something was wrong. Do you see why I checked my answer here? Okay, negative 1. Negative 1 squared is 1. That becomes positive 1. 2 plus 1 minus 3 does equal 0. And it checks. Let's try number 10. A is 6, B is negative 4, C is negative 4. So it's already set equal to 0. There is no greatest common factor. I'm going to go ahead and factor this. Okay. A times C, so 6 times negative 4 is negative 24. My B value is negative 5. That always goes down here. Let's think of our numbers. You get stuck like I am, you could just write them out. Larger number on the left. Oops. Any of those match? Found my winner. All right, what combination of positive and negatives here? This is going to be negative 8 times 3 is negative 24, and negative 8 plus 3 is negative 5. So my two numbers for my B value are going to be add an x, top, bottom left, top right. 6x squared, and our negative 4. Let's take out the greatest common factor of the top row. This would be 3x. Next row would be negative 4. Greatest common factor of the first column on the left there, this is going to be a 2x. And this one will be a plus 1. You can double check by multiplying 3x times 2x, 6x squared, 3x times 1, 3x, 2x times negative 4, negative 8x, and negative 4 times 1 is negative 4. Okay, so 2x plus 1, 3x minus 4. Set them equal to 0, and let's solve them. Divided by 2 here, that gives you x equals negative 1/2 as a solution. And 3x minus 4 equals 0. Remember, PEMDAS backwards, add first, add and subtract. And then divided by 3 here. Answer. Okay, let's go ahead and check our answer. 6 times 4/3 squared minus, ooh, it's not going to be fun. I shouldn't say not fun. Not easy. 6 times, okay, square that. So 4 squared is 16. 3 squared is 9. Minus 20 over 3 minus 4. So I got 96 over 9 minus, I'm going to make an equivalent fraction to be 60 over 9. Do you guys know why I did that? I did that because I want to subtract these two. So that'll give me 96 minus 60 is 36. And 36 divided by 9 is 4, and 4 minus 4 is 0. So that matches. Okay? Let's go ahead and check 4/3. What? That was great. Okay, sorry. I'm coming down. X equals negative 1/2. 6 times negative 1/2 squared minus 5 times negative 1/2 minus 4. Okay, 1/2 times 1/2 is 1/4. Just multiply across. Negative times negative is positive, and that gives me positive 5/2. So this will give me 6/4 plus, multiplied by 2 over 2 would give me 10/4. I'm getting an equivalent fraction, and the reason I'm doing that is so that I could subtract this problem right here, or add. So 6 plus 10 is 16 over 4, and 16 over 4, so 4 minus 4 equals 0, and that checks. That was question number 10. Let's go to question number 11. Set equal to 0. 5, 20, and 12 do not have a greatest common factor. I'm going to go ahead and identify my A, B, and C. A is 5. B is 28. C is negative 12. They are never ever has an X in it for the A, B's, and C's. Let's go ahead and use our Xbox method of factoring. And it might be helpful for you to always write up the letters, A times C. So 5 times negative 12 is negative 60. My B value is 28. All right, we need to think of numbers or factors of 60. So you'll notice I have the larger numbers on the left. I like to count down, so 3 and 20, 4 and 15, 5 and 12, 6 and 10. Okay, do any of those help us? They do not, blah, blah, blah. Did we miss anything? Five is 0 extra 1, 60. 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm missing something. All right. I'm going to show you my trick. Let's see if this works. Y equals clear 60 divided by X. Second table set auto. Start at 1, do 1. Table. Okay, so 60 divided by, okay, so it's telling me all the factors right there. I don't know if you recognize that. 60 divided by 1 is 60, so 1 times 60, 2 times 30, 4 times 15, no. 12 and 5, no. 15 and 4, no. 20 and 3, no. 30 and 2, duh! You guys were probably staring right at it. I don't know, I just had to see it. Why did I write 15 times 2? That's why. Did you guys see that? Come on, Mr. Ring. Okay, so 30 minus 2 equals negative 60, and 30 minus 2. 30 times negative 2 equals negative 60. 30 plus negative 2 is 28. Add an x here. Those two are always going to go in the bottom left, top right. 5x squared, always, and then negative 12, always. Okay. Top row, left and right, greatest common factor is an x. You can kind of cheat, so go to the greatest common factor of the column. This would be 5x, so this one's going to have to be a 6. Over here, it's going to be negative 2, and negative 2 times 6 is negative 12. So, x plus 6, right there, and 5x minus 2. Let's go ahead and solve that. Remember, PEMDAS backwards to solve. X equals 2 over 5. Whoop, whoop. All right, x plus 6 equals 0. Subtract 6, you get x equals negative 6. Let's check our answer. 5 times negative 6 squared plus 28 times negative 6 minus 12. Why do I do that? So 5 times 36 times 28 times 6 gives me 168. 5 times 36 is 180. Minus 168 is 12, so 12 minus 12 equals 0. Matches. Alright, let's do the fun, wonderful fraction. 5 times 2/5 squared minus 20 plus 28 times 2 over 5 minus 12. Does that equal 0? So exponents first. We are simplifying here, so I'm just using PEMDAS, which means parentheses and exponents. So 2/5 times 2/5 is 4/25. And this one is going to be multiply across, so 56/5. And this multiply across, you'll get 20/25. This one I'm going to multiply by 5, so yeah, this is going to work. 0 extra 3, 280/5, 25. So this will get me 300 divided by 25, which is how many quarters in $3? That will be, I'm assuming, 12. And 12 minus 12 is 0. Works out. Okay, let's go on to questions 12 to 14. Complete 2 of these and then go ahead and skip one of them. Same idea here. Alright, question number 12 to 14. Complete 2 of these, skip 1 problem, solve each equation by factoring. Alright, so this one's already set equal to 0, and there is no greatest common factor. So I'm just going to identify my A, which is 12, B is -8, and C is 1. A times C is 12. My B value, which is -8. You can write out the factors. I think we got a winner there. 6 and 2. Okay, so I multiply them, they equal, so both negative, yeah? -6 times -2 is positive 12. -6 plus -2 is -8. Let's go ahead and alright, what am I doing with this thing? Okay, so B value, these two will always go bottom left and top right. Always. There I have 12x squared. That one, the whole thing will go in the top left always. And then bottom right is positive 1. That value, the C value, always in the bottom right. Okay, now we're going to take out the greatest common factor for the top left, top row. This one's going to be a 2x. And the bottom row is a little tricky, so I'm going to go the other way and you can kind of see your answer. So the first column to the left, the GCF would be 6x. And this one has to be a -1. How do I know that? You can multiply, right? 2x times 6x is 12x squared. 2x times -1 is -2x. And so obviously that one has to be a -1. Because -1 times 6x is -6x. -1 times -1 is positive 1. Ooh. Alright, let's get 2x minus 1. And this one, 6x minus 1. And I just want to draw your attention to the future that basically we started from the inside of the box going out. Next unit or module or chapter will go from the outside in, which is just multiplying, which I've actually showed you there. Alright, 6x minus 1 equals 0. Add 1 to both sides. 6x equals 1 divided by 6x equals 1/6. Okay, so 2x minus 1 equals 0. Add 1 to both sides. 2x equals 1. Divided by 2, x equals 1/2. Remember, what you're doing here is your A value is positive 1/2, x equals 1/2, x equals 1. Whoa. I know, 1/6 is actually there. And your graph is like something like that. And then your C value is like 1. So remember, we're trying to see those blue and purple dots. Let's go ahead and quickly check our answers here. What do we got? 1/6. 12 times 1 6 squared minus 8 1 6 plus 1. 1 6 squared is going to be 1 over 36. Just multiply across, you'll get negative 8 over 6 plus 1. Is this equal to 0? Put it over 1, 12 over 36. I'm going to multiply this one by 6 over 6 so that I can get negative 48 over 6. Whoa, 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 whoa. Over 36. No, something's wrong. No, that's right. 12, negative 48 is negative 36 over 36, which is negative 1. And negative 1 plus 1 equals 0. All right, let's do this one right here. 12 times 1/2 squared minus 8 times 1/2 plus 1 equals 0. 12 times 1/2 squared. 1/2 squared is 1/2 times 1/2. So you just multiply across and you'll get 1/4 minus 8 over 2. Multiply across, 12 over 4. This will give me negative 16 over 4. And that'll give me negative 4 over 4, which is negative 1. And negative 1 plus 1 equals 0. Whoop, whoop. Okay, number 13. Set equal to 0. Yes. Set equals 0. Greatest common factor. 2, 11, and 40 are not multiples of 11 or are not all even. So we're good. A is 2, B is negative 11, and C is negative 40. Xbox. Okay. A times C, so that would be 2 times negative 40 is negative 80. B value is negative 11. So let's write down the factors, 80 and 1, 40 and 2, 4 and 20, 5 and 16. 8 and 10 if you need it. 16 and 5. What two numbers will multiply by negative 8 but add to negative 11? So that'll be negative 16. So negative 16x, 5x, 2x squared. And negative 40, negative 40, negative 40. Is my C value. Always put it up there. Okay. Top row. The GCF is X. Bottom row. Negative 4. Is that right? Left column. 2x. Now I know why this is wrong. Why is it wrong? 2x times negative 4 is not negative 16. Does that make sense? So this is a greatest common factor of an 8. That makes sense. And this one will be a positive 5. So let's multiply x times 2x. 2x squared. X times 5 is 5x. Negative 8 times 2x, negative 16x. Negative 8 times 5, negative 40. Done. So x minus 8. 2x plus 5. And remember, check your answer. We've done that before in the warm-ups. Was you can use your FOIL. All right, 2x. What happened to my pencil? 2x plus 5 equals 0. Subtract 5 from both sides. 2x equals negative 5 divided by 2. X equals negative 5 halves. Oh yeah. Okay. X minus 8 equals 0. We're doing the zero product rule. We're setting each of those binomials equal to 0. And add 8 to both sides. X equals 8. Let's double check our answer. 2 times 8 squared minus 11 times 8 minus 40. 2 times 8 squared is 64 minus 11 times 8 is 88 minus 40. 64 times 2 is 128 minus 88 is 40, and 40 minus 40 equals 0. All right, 2 times negative 5 halves squared minus 11 times negative 5 halves minus 40. Negative 5 halves squared is negative 5 halves times negative 5 halves. Negative times negative is positive. 5 times 5 is 25 over 4. Negative times negative is a positive. That would be 55 over 2. So multiply across here. So that would be 50 over 4. I need an equivalent fraction here. So this will give me 110 over 4. 25 over 4. 55 over 2. 10. Okay. Let's see. That is right. It is right. Oh yeah. So 160 over 4 is 40. And 40 minus 40 is 0. It works. Number 14. Oh, the little tricky ones they gave us. Is it set equal to 0? No, it's not. So this is a common mistake here. Students would normally, who make a mistake, will say C equals 21. C equals 21 is wrong because it has to be set equal to 0, like this. See? See? C is actually negative 21. Big, big, big mistake. Okay. Let's do our X box. Okay, A times C is 3 times negative 21, which is negative 63. My B value, which is 2. Let's write all the factors. 63 and 1. No 2, 3 and 21. 9 and 7. Any of those match? Winner, winner, chicken dinner. 9 times negative 7 gives me negative 63. 9 minus 7 gives me 2. 2x is 9x, negative 7x. 9x, negative 7x. They always go in those positions. Always. 3x squared and negative 21. Okay, so let's go through the rows. This is x is your greatest common factor between 3x squared and negative 7x squared. This one looks to be a 3. I'm thinking a positive 3. If I go up here to the top column, that would be 3x and negative 7. Does that work? Yes, it does. Check your answer. X times 3x, 3x squared. X times negative 7, negative 7x. 3x times 3 is 3x, 3x, 9x, and 3 times negative 7 is negative 21. So we have x plus 3 and 3x minus 7 equals 0. Okay, so 3x minus 7 equals 0. Add 7, 3x equals 7. Divided by 3, x equals 7 thirds. And over here in the purple, x plus 3 equals 0. Subtract 3, x equals negative 3. Okay. Let's check our answers. Just using the original equation up here. PEMDAS. So we are simplifying, so we're going down. So parentheses exponents, 3 times 9 minus 6, does that equal 21? 27 minus 6 does equal 21. Thank you. Okay, 7/3. 7/3 squared times 3 plus 2 times 7/3. And does that equal 21? 7/3 times 7/3 is 49 over 9. Make a fraction by any whole number by putting over 1. So I get 14 over 3. I want an equivalent fraction over here. So I notice that it's a 9. So I need to get that one to be a 9. So 7 extra 2, 12, 147 over 9. Feel free to use your calculator. 14 times 3 is 242 over 9. And this will give me 189 over 9. And that 9 goes in 18 twice, 9 and 9, 1. Yay! It checks. And that was number 14. All right, let's go over 1.50, factoring the difference of squares. Basically, this means b equals 0. I'll show you guys the formula, but I don't like memorizing this formula. A squared minus b squared equals a plus b, a minus b. And the reason why I don't, because it's just like another formula to memorize, and it's kind of easier if you just use the Xbox method. So let's go ahead and try this example with me. It has 81 minus x squared. I will show you guys the two methods, and you can choose which one works for you. It's just hard to distinguish when to use each of these methods. Okay, 81 equals x squared. Okay, my method is to keep using the x box. And it seems long, but you'll recognize that it's more universal. It's kind of like having Air Force Ones. They are classic. Okay, x squared minus 81, and you're going to notice that I left a big space in there because that's the point of difference of squares. The b value is 0. And then here you can just use your Xbox method. Your a value is 1, so a times c is negative 81. My b value is 0, right? A, b, and c. Two numbers that multiply to be negative 81 are positive 9 and negative 9, and they add to be 0. Basically, that 9x and negative 9x, if you add those together, equals 0x. That term always goes in the top left, and then the bottom right. And then if you finish this up, take out the greatest common factor of the first top row here, that would be x. This one would be a positive 9. Greatest common factor of this column would be x, and this one would be negative 9. And so you would have x plus 9 and x minus 9. And we're doing the same thing here. Solve each of the equations by factoring and check your solution. Set it equal to 0 and solve. And then to check our answers, I can just put it back into the original equation. 81 equals negative 9 squared. And that is true. And this particular problem is also verifying why, when you do it by the square root method, whoops, we're supposed to put 9 in there. And that is true, right? That would be 81. Remember the square root method. I'll show you over here in green. You take the square root, and you can't say x is equal to 9 because we just boxed 2 answers there, and here you only have 1. That is the reason why you have a plus or minus. Okay, so let me go ahead and show you guys now the formula and see how, in some ways it might be like a shortcut, but it's hard sometimes to distinguish. Okay, so I have 81 equals x squared. I'm going to subtract 81 from both sides. And we're left with 0 equals x squared minus 81. Okay, the formula has something squared, so I'm going to put an x into the parentheses. And this one is a 9. Okay, and then in some ways you're going to do this. The square root of x squared is x. And then the square root of 9 is, I'm sorry, square root of 81 is 9, so you have a 9 here, and one's plus, one's minus, and then you would just solve it, so you get x equals 9, negative 9. The point is that you have to recognize that it is a particular formula. The number one mistake is like it has to be a subtraction of squares. That's why they call it difference or subtraction of squares. Okay, so pick one of those methods and see which one works for you. Again, you're going to see what becomes hard is they scramble them all up. Go ahead and for questions 15 and 17, go ahead and skip 2 of those. I'm going to go ahead and show you guys 15 by just using my method. Remember, b is 0 here. So a is 1, b is 64, so negative 64. My b value is 0, that's why I said that the b here is 0. And two numbers that multiply are 8 and 8, and that'll be, if you'll recognize that these will always be the same number, but one's positive and one's negative. So they multiply to be negative 64 and add to be 0. That is the middle term, 0x. So I'm going to put an x here. Bottom left, top right. That one always goes into top left and the bottom right. And then if you just take your guys' common factor, you'll get x, negative 8, x, and positive 8. And then solve, you just set each of those equal to 0. So you get x equals 8 and x equals negative 8. All right, let's try number 16. It's nice because it's set equal to 0. And then I'm just going to have to use my x on my box. A times c is, remember this is x squared plus 0x minus 100. A is 1, b is 0, c is negative 100. So 1 times negative 100 is negative 100. My b value is 0. My numbers are going to be, remember it's the identical one, so 10 and negative 10. You're going to put those here and here always. That was this term, 1x squared or just x squared, and then negative 100. GCF here is going to be, whoa, I was trying to do a fancy x. X, positive 10, x, and negative 10. So that becomes 10 and negative 10. Set both of those equal to 0. And then you just solve. So subtract 10, you get negative 10 here, and over here you get positive 10. Those are our two solutions, and then we forgot to check our answers. That would become 100 minus 100 equals 0. And same thing over here. So that is true. On the previous problem, that is true, right? Negative 8 times negative 8 is positive 8. Same thing if we did a positive 8 squared. And number 17, I'm going to set this equal to 0. I left a big space in there so that, remember this is the point of the lesson. For this particular section, b is equal to 0. This little placeholder is super important to us, especially as you division of polynomials later on. So you have a is 1, b is 0, c is negative 289. So a times c, so that would be 1 times negative 289. You have a b value that is 0, 289 times 1. I don't even know the other ones, but I already know it's going to be 17 squared. And then those are my numbers. Again, in this difference of squares problem, they will always be identical, one positive, one negative. That's splitting this term here. Oops, that looks like a positive, doesn't it? Oh, that's what it was. That was a 1. X squared and negative 289. Greatest common factor down here is x, positive 17, x, and negative 17. So that'll give us x plus 17 and x minus 17. Set those each equal to 0 and solve. And then you can check your answer. That's what it means to solve. Find something that's true. As you have seen that I'm checking my answer, I both actually found I've messed up, so you might do the same thing. All right, questions 18, 19 to 20. Go ahead and complete 2 of those. So skip 1 problem, solve each equation by factoring, check your solution. Remember, that is not 14 is not a b value. If you subtract 50, you'll get x squared plus 0x minus 36. And then hopefully you're getting really good at this x in this box. You don't have to label it. Eventually I see students do this. A times c is negative 36. B value is 0. My 2 numbers are 6 and negative 6. And some of you guys see the shortcut. There is an x. I was about to tell you, but I said no, won't do that. I want to cheat you out of the learning. Negative 36. And then you're going to factor out the greatest common factor of this row, this column, and this column. And then go ahead and split those, set them equal to 0 for the zero product rule. And you get your two solutions. Remember what we're doing. We are essentially graphing -6, +6, and the c value of -36. In this case, this is called the power function because there's no b value. Basically what that means is the y-intercept is, in this case, the vertex. That only happens for the quote-unquote difference of squares problem, or we'll learn later on that it is a transformation. All right, let's go ahead and check our answer. -6 squared plus 14, does that equal 50? 36 plus 14 does equal 50. We'll check the +6. And same thing, 36 plus 14 equals 50. Let's go ahead and try number 19. And I'll show you guys the other method. But you have to know your perfect squares. Why do they call it a perfect square? If this is 13 times this 13, I don't want to draw it, but this is 169 little boxes. That's why I call it a perfect square, because it's really 13 squared equals 169. Is that pretty neat? Okay, so if you put this into the formula, again, this is just the other way of solving it. The formula is a plus b, a minus b. So if a is equal to x, and b is equal to 13, then you get 1 plus, you get 1 minus. Let's set it equal to 0 and solve. Low diagonal. Okay, and then we gotta check our answer. So 13 squared minus 169, does that equal 0? 169 minus 169 does equal 0. Yay, yay. Negative 13 squared minus 169 equals 0. We're not sure. 169 minus 169 minus 169 is equal to 0. Ooh, look at this one. How do I do it? How do I do it? Alright, let's, I'm going to subtract 124. My pencil turned off. You're going to get 0 equals x squared minus 121. Remember, we're trying to get it where you have a the b value is, we said, way up here equal to 0. That's why it's called difference of squares. And now you can use your x box. Okay, so a is 1, c is negative 121. So 1 times negative 121 is negative 121. B value is 0. my two numbers are going to be 11 and negative 11. So this splits this one, so that'll be 11x, negative 11x. Those two on the side, these two, always go in these two positions. Just make that clear because it's splitting this term. Okay, so this one, that whole term, always goes here where it's green. So that means this would be x squared, always. And then the c value will always go in the bottom right, always. So hopefully this color coding or pattern helps you. All right, the greatest common factor of the row is x. This one's a positive 11, x, and negative 11. And then there you just solve it. Those are our two solutions. Let's put it in there. Check it. So 121 plus 3 equals 124. And then 124 equals negative 11 squared plus 3. So again, that's negative 11 times the negative 11, which is positive 121 plus 3, which equals 124. All right, 1.46, they call this factor the perfect square trinomial. And right there I have a parenthesis squared, and really that's what happens. You'll see. So, go ahead, number 1, complete or do this with me. So let's do this example. Ooh, they give us a crazy one. We're going to do the same thing, solve by factoring, and then we're going to check our answer. It's crazy. Watch. That's my y. Has a little tail. And if you do the steps we had way before in the very beginning, up here, right? Make sure you're setting it equal to 0. Most of the time they haven't had the greatest common factor. Make sure it's in standard form where a is positive. Identify the a, b, and c. Do the x and the box. Sorry, those colors didn't save. My iPad. Wow. Okay. So here, I want to make sure that it's set equal to 0. And I wanted my a value to be positive, so what I'm going to do is I'm going to move everything on this side. We're doing opposites. Basically, what the opposites does is this. They call them properties of equality. That's 0, 0, so that's now set equal to 0, and it's kept my a value positive. Okay. There are going to be some very large numbers, and we can do something. What did we call this before? They call this the chunking method. And I still think this chunking method is better than using the formula. So the chunking method says I take out this one and this one. 16y squared. And really this is 4y squared. Would you agree? And so I'm going to say that 4y is equal to x. Watch how we use this chunking method. So I can have, again, let's do that again, 4y. Now the square's on the outside, okay, and this one is going to be minus 12 times 4y. Let's see if this works, okay? Every time I see 4y, I'm going to write x. I see 4y, now I'm going to write x. I see 4y, I'm going to write x. Okay, what that did is I went from some crazy large numbers. So instead of me doing something like this, a times c, that would have been 16 times 46, you would have gotten some huge number. I've actually made it a lot smaller. And then I can just factor this. Let's just use that right here, what I got. Okay, a is 1, b is 46. So I got 46. And my b value is negative 12. So 46 and 1, 23 and 2. I think that's all we got on it. I can't add. As you can see, I can't add up here. That's 36. That might make my life easier. Let's try that again. 36 and 1, 2 and 18, 3 and 12, 6 and 6. So my winner, negative 6 and negative 6. Alright, negative 6 times negative 6 is 36. And negative 6 plus negative 6 is negative 12. So I have my box. I turn into an oval. And here, okay, we're not going to do our substitution yet, but let's use our colors to our advantage. So I have x squared I have negative 6x and negative 6x, which is right here. And then positive 36 is my C value. Okay, so now I'm just going to take out the greatest common factor of each row. And this would also be, so here I have x minus 6 equals 0. And then what you can do here is you can do your substitution. So we had said that every time we see x, we can write 4y. So now let's do that. I have 4y, there's 4y, and then you have minus 6. Okay, from here you can do two things. You can do something like this. You can put them together and then solve by the square root method. Plus or minus 0. Well, we don't say plus or minus 0. If I take your wallet and add 0 to it, nothing changes. So you're just left 4y minus 6. You might as well call it just 4 minus y is 6. 4y minus 6 equals 0. And then add 6 divided by 4, which which is this would give you y equals 3 halves. Is your answer. You could have also here, you could have separated them 4y minus 6 and just solve, and you'll get 2 of them. Y equals 3 halves and y equals 3 halves. I like that better because that kind of shows that there is it's a double solution. The formula they like to give, which again I think it's just another thing. I'm not going to show you it too. It's just not fun. Do you want to see it? Okay, just because you asked for it. It's really not that fun. But hey, if you want to see it, a plus b quantity squared is a squared plus 2ab plus b squared. Yeah, that one looks fun. So I think the chunking method helps. It's a strategy we actually use in higher level math to make problems a little bit more simpler or more bite-sized. All right, for questions 21 to 23, go ahead and complete those two. Complete 2 and skip 1, and then solve each equation by factoring. All right, so let's go ahead and look at the chunking method here. You're really just looking at the fronts right here. And you're basically seeing what do they have in common. What they have in common is a 2x. So this will become, let's go the other way. Any variable you want, I'll call it, I like w, I don't know why. W equals 2x. How did I get that? I got this from here. 2x squared minus 14 times 2x plus 49. And then every time I see 2x, I can write w. So I see 2x, I'm going to write a w. I see 2x, I'm going to write w. So you get this. And those parentheses go away, right? And then you can just do your A, B's, and C's, right? A is 1, B is negative 14, C is 49. Did anyone pick up the trick on this Xbox method? Okay, so you have A times C, which is 49. My B value is negative 14. My two numbers, that would be identical. Positive 7 and nope. That's going to be negative 7. Negative 7 times negative 7 is positive 49. Negative 7 plus negative 7 equals negative 14. So that represents the middle term here, so I'm going to add a w in there. You could have used x if you wanted to. And 49. That last term is always in the bottom there. And then greatest common factor, w, negative 7, w, negative 7. Okay, before you want to put back in the substitution, this might be a great time to put in your substitution. Every w is 2x, same color, and because you have two of the same thing, you don't need to do the problem twice. Add 7 to both sides and divided by 2, you get x equals 7 halves. And that's actually a double root. Double root. You're just noting that if you did this same problem over here, you'll get x equals 7 halves. So you're actually getting it twice. And remember, that's important because if you actually graph this, let me graph. 7 halves is 3.5, and basically, you have the y-intercept c value, and it's going to go something like that. Does that make sense why it's called the double root? This actually represents 2 reals. And we forgot to check off work. Oh, yes. Okay, if you did that, I'm happy to check our work. So this will give me 4 times 49 over 4, 28 7 halves, plus 49. So this will get me 49 times 4, 196 over 4, minus 28 times 7, 196 over 2. 196 over 4 minus 196 times 2 is 392. And 196 minus 392. And that's negative 196 divided by 4 gives me negative 49, which equals 0. Boop. Alright, number 22. 9x squared plus, don't do 7x, that's 6x plus 1 because they're not like terms. And then pick your favorite variable. I'll call mine y. Why, Mr. Ing? Why did you pick that? Well, if I put 3x in here, I'm trying to get the ones in parentheses to be the same, because then I can do this. Every time I see 3x, I can write y. I see 3x, right? Y. It just makes the problem a lot smaller. Now that one's doable, but I'm just showing you. And again, this only works when you can take out the greatest common factor, basically, of the first 2 terms. Okay, so that would give us this. A times C, my value is 1. B value is 2. 1 and 1. We're splitting this term here, and that one goes here, and then you take the greatest common factor. Y, 1, Y, 1, Y plus 1, Y plus 1. And then here, this is where I would do my substitution. And if you set one of those equal to 0 and solve, 3x equals 1. Oh, see? That's why you gotta go slow, Mr. Ing. Double root. Okay, let's do number 23. Set it equal to 0, same thing. Let's see if we can do this chunking method. Again, the chunking method only works for the first 2 terms. Let's pick our favorite letter. Let's pick W. What do you think it's going to be? What do you think? Well, something squared equals 16x squared, that's going to be 4x. Because if I do 4x times what? 6 gives me negative 24x. Here is our substitution. So every time I see 4x, we're going to write w, 4x, we're going to write w squared minus 6w plus 9. And now the problem's a little bit more manageable for us. So a times c is 9, b is negative 6, negative 3, negative 3. What are we splitting here? Okay, a is 1, or that always goes here. That one always goes here. So greatest common factor, w, negative 3, w, negative 3. Remember, you can always, you can multiply to check your answer here. W times w is w squared. W times negative 3 is negative 3w. W times negative 3w. W times negative 3 is negative 3w. And then negative 3 times negative 3 is positive 9. Well, that's a 0. And then here I'm going to do my substitution back in. Right, every w we see, we're going to write 4x and then just set it equal to 0. Solve, add 3 to both sides, divide by 4, careful, x equals 3/4. Double. Why is it double? Because you're basically doing the same thing again over here. Okay? All right. Questions 24 to 26 basically do the same thing. Do 2 of them, skip 1, press pause. If you want to see me do it, well, just keep watching. What a nice blue that is. Wow, wow, dropping my pen. Alright, I'm going to set it equal to 0. Alright, I'm going to see if I can do a substitution for this one. So is there a greatest common factor for each of those? Yes, yes, yes. 9? What do you guys think? 9? Okay, so that would be 4, right? 4 times 9x plus 4 equals 0. So 9x is equal to w. Do you like w? Too bad. 9x equals w. Put it here, 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 here. So I get w squared plus 4 times w plus 4. And then do the x in the box. A times c, so this a is 1, b is 4, c is 4, so a times c is 4, b value is also 4. And my answer is going to be 2 and 2. So that is 4w. So 2w and 2w. This one always goes top left. This one always goes in the bottom right. And then we just take our greatest common factor. So w, 2, w, 2. You'll like those in the future. W2s, all your taxes. separate the binomials, set it equals 0, solve. You could do something like that. That kind of looks weird, but you have 2 of them, right? Oh no, we haven't been checking our answers. 81. That gives me 81 times 4, which is 324. This will become minus watt, minus 72. That does not sound right. Oh. Do you see why it doesn't make sense when I check my answer? Watch this. 324 minus 72. And I know why. 252. Is 252 equal to negative 4? The answer is no. They are not equal. Well, what happened? Hopefully you caught my mistake. Is we forgot to substitute back in 9x for w. That's what I forgot. Hopefully you caught that. That goes here, here, here. I think I even wrote it. Just, what are you thinking, my darling? Okay, so 9x. So 9x plus 2 equals 0. 9x equals negative 2. X equals negative 2/9. So negative 2/9. Negative 2/9. This would be double, right? There's 2 of them. The best one right here would just be to cross multiply, really. But I'll show you what happens. 81 times negative 2 times negative 2. So 81 times 4, 324 over 81. This one's going to be negative. Negative 72 over 9, which I need to now multiply by 9 over 9. 648. It's supposed to be a negative. So 324 minus 648. This gives me negative 324 over 81. So divide my answer by 81 and get negative 4. Woo! Okay, greatest common factor now. Set equal to 0. Yes. And let's see if we can do our chunking method. You guys see something in there? Just take the first one and really take the square root of it if you think about it. Well, if I want them to be 5x's, this is going to have to be 16. Favorite variable, how about y? Okay, so every time I see 5x, we're going to write y. I see 5x, write y. Everything else is the same. And then I can do this, x box. And A is 1, B is 16, C is 64, so A times C is 64. My B value is 16. My 2 numbers are 8 and 8. And we're splitting this one. So take greatest common factor of this row, greatest common factor of this row, this column, and let's not make the mistake we did last time, which was to do our substitution. Y plus 8 equals 0. And then every time I see y, I can write 5x. Now you could do this without the substitution. You're just working with super large numbers. Set that one equal to 0. Solve. Oops, that should be negative 8. And, geez, Mr. Rain. 5, just, my brain dead. X equals negative 8/5. Double root. All right, 26. Add 5. Let me show you how it is possible to do this without the chunking method. Whoa, Mr. Ing, whoa. Okay, A, B, C. A times C is 900. My B value is 60. So I'm thinking 30 and 30. So that would be 30x. Do you realize how large these numbers are? Whoa. Let me check. Okay, let's see. 3x. How about 10? 3x and 10. So 3x plus 10. 3x plus 10 equals 0. And that looks like a 20. Sorry, guys. Sorry. So tired. Not an excuse. Alright, subtract 10, divided by 3. Here's another way of writing this. You can call this a multiplicity of 2. Basically says you have 2 of those. And we haven't been checking our answers, huh? Wow. So it's doable, it's just the numbers are super large. Okay, so square both of these numbers, that would become 100 over 9. And this one's going to be, let me show you guys how I like to simplify these. It is cross canceling here, but 3 times 20. Why did I change 60 to be 3 times 20? Because I looked ahead and I realized there's a 3 down here in the denominator. Does that make sense why I did that? 9 divided by 9 is 1. So 20 times negative 10 is negative 200 plus 100. $100 bills, and it checks off. Wow. Alright, let's spice it up a little bit. I'm on my iPad, and then you can go to settings or accessibility, but I'm going to do something called Smart Invert, and I always like this dark mode. Okay, we're on the last part, 1.47, complex solutions, and I'm going to show you guys a couple of ways to do this. Let me show you guys the textbook way. So, method number 1, textbook. And the problem is x squared, let's do it maybe over here, x squared equals negative 144. And we're doing the same thing, we're solving this by factoring. And I want to show you that if you add 144 to both sides, you get x squared plus 0x plus 144, and then you would try to use your xbox method, and then you would do something like a times c is 144, and then a b value of 0. Now pay attention, you couldn't do 12 and negative 12, because although that adds to be 0, that would multiply to be negative 144. So our method of factoring here does not work. So the textbook says, the textbook would say add 144 to both sides, and then I have x squared plus 144 equals 0. And then you change the 144 to opposite of a negative 144. And the reason why they're doing this is so that you can do, this is going to be hard. How do I multiply two identical numbers to equal negative 144? We just talked about you can do 12 and 12, or negative 12 and negative 12, but you can do something. We can call in the pirates. Let's call in the pirates. Let's call in the pirates. So you can do negative 12i squared. Okay, what does that equal? That equals, so negative times a negative is a positive. 12 times 12 is 144. And I times I is I squared. And remember, what do the pirates say? I is square root of negative 1, or I squared is equal to negative 1. So if we remember this information, then we can say that's negative 1 I meant to do that in pink, and negative 144. Okay, so that means that I can put in here negative 12i, or there's a second one, I can choose positive 12i. That would equal the same thing, right? 144 gives me I squared, and then I squared is negative 1, and I get negative 144. Okay, so the one I'm going to choose is I'm going to choose the positive 1. So now I have parentheses x squared minus parentheses 12i squared equals 0. And the reason why I want to do that is so that I can use the formula difference of squares, which I showed you. And the formula then is a plus b, a minus b. I told you I don't like memorizing formulas, but I have not seen a way to figure that out by using the Xbox method of factoring. So if you know it, let me know, and we can do it. Okay, so my a value is now x. Let's get the right color in here. And my b value is 12i. So b value 12i, 12i, and then you kind of go through in here. So what we've done so far is we factored x squared plus 144. Let me highlight that for you. We factored it here to equal this, okay? And then now we just need to solve it. I can solve this by setting it equal to 0 and subtract. You get x equals negative 12i. And then over here, we do the same thing. Add it to both sides. you're going to get x equals 12i. So basically equals positive negative 12i. So that is the textbook way of getting a solution by factoring. Okay, let's go ahead and show you guys my method. And it is faster, but I gotta say it'll give you the answer, but it's not using factoring. So if you were doing a free response quiz or test for me or another math teacher and it tells you to do it by factoring and you still get, you don't use factoring like this method I'm going to show you, because what I'm doing is I'm using the square root method. And just pretend you're becoming a cook and they say cook the potato by baking it. And you boil it and you're still getting a cooked potato, but you're using the wrong method. And that's the same thing here in math. So let me show you what I'm talking about. So I have x squared equals negative 144. And you can show the work, but I'm saying you're kind of using an indirect way of doing this. Just sometimes okay. Okay, so the square root method says once the x squared is isolated, I'm going to take the square root of both sides. You're left with x equals, now you have to do the plus or minus the factors of negative 144 and negative 1 times 12 times 12, right? And then the square root of negative 1, that becomes your I on the outside. And then you have a pair, so those can come out. So our answer is x equals plus or minus 12i. Now, I want to show you guys how fast that was comparatively. Here's my solutions here, and here's my solutions there. So essentially I have the same answer. Now, if they ask you to factor it first, you can just do this. Now that we've done the problem with the square root method, you can say add negative 144, move the negative 144 to the other side, so you have this. Okay, we haven't talked about this, so this is a little bit more advanced. And I'm going to show this by colors. That's hopefully you guys see why I do colors. Okay, so what I'm going to do here is I'm going to put in here each of these. And what I wrote there in the white formula is for x-intercepts or factored form, which we are actually talking about. So one was a positive 12i and one was a negative 12i. Okay, so then you'll get x minus 12i and x plus 12i. And what I'm trying to prove to you is, so if you're doing that super clean on a quiz or test, you have x squared equals negative 144. So I'm kind of doing this from the beginning. You would add both sides, x squared plus 144 equals 0. And then you would use this, what we just did right here, down here. So then this is, I'm showing that you factored it. Most math teachers are just more concerned that you know how you got these binomials, or just that you have the binomials. You can use guess and check, tic-tac-toe, you can use my Xbox method. Does that make sense? And then you can just say that the answer is 12i and negative 12i. So down there, hopefully that was, that's my method. It's kind of indirect, but you still get the answers. So as you do the next couple of problems, you can choose which method you want to use. As you can see, both methods give you the same solution. You can also show the factored form. And I'll probably go, let me show you guys, 27 to 29, I'm going to use the textbook method. And then questions 30 to 32, I'll use my method. For 27 and 29, go ahead and complete 2, and then you can go ahead and do press play to see the solutions. All right, let's go ahead and use the textbook method here. Let me write this above so I don't forget. Textbook. And really, it's not my method, it's the square root method. Okay, for number 27, let's move this to the other side. So I now have x squared plus 25 equals 0. In order to use the difference of squares, we have to change it to subtraction. So how do I do that? We do minus minus. So now I have x squared minus negative 25. I'm sorry, that is wrong. It's I guess I skipped a step. Sorry. X squared minus minus a negative 25. And then if you want to, we have to kind of take the square root of both x squared and 25, which gives you the negative 5. And I forgot the I. So let's double check that really quickly. This one should not be. Okay, so let's double check. I'll do it over here on the side. Negative 25, is it equal to 5i squared? And 5 squared, and then you have I squared, right? So that's 25, and then I squared is negative 1. And that is true. What? Negative 12, negative 25. Now, if you get stuck on this part, let me show you another method that you can do something like this. Negative 25 equals x squared. You're solving for x, and that's what goes inside the parentheses, if that makes sense. So if I take the square root of both sides, you're going to have x equals plus or minus. You have to write that every time you do the square root of an equation. You're solving an equation. The factors of negative 25 are negative 1 times 25, so the square root of negative 1 is I, and the square root of 25 is 5. So in some ways you have two answers to put in there, but we talked about in the do it with me problem that I want just the positive 5i. Let me write that in blue. And the reason why I want that is so that I can have it in this form. I always write down the formula, super helpful for me. And this is, if you can see it, this is called the difference of squares. Does that make sense? Let me highlight that. Difference of squares. And the formula I need to write for that is a plus b, a minus b. So the a value, let's just use some a value, is going to be now x. Okay. This thing's too big. The b value is 5i. And then we can just go back and fill in everything. So x plus 5i, x minus 5i. And then just set it equal to 0, zero product rule, and this is where now, so that's factored right above, and now we're just setting equal to 0 to solve. You do the opposite to move it across, and then you have this as your answer. Okay? That is solving number 27 using the difference of squares. Let's try number 28 with difference of squares. It's already set equal to 0. I'm going to change this to a minus. Pencil work. Okay, so Alright, so I need something in here. And what you can do is, what am I going to put in there? Right, so you can do negative 100 equals x squared. No, we shouldn't use x. Let's use w. Does that make sense? The pink one is parentheses squared, so I'm calling that w squared. I take the square root. You must have a plus or minus. So the square root of negative 1 times 100. And then the square root of negative 1 is I, and the square root of 100 is 10. So you have plus or minus here. And we talked about how you're going to just take the plus. So you're just going to write in here 10i. 10i squared is equal to negative 100. 10i squared is equal to negative 100. That would be 100, and I squared is equal to negative 1. Does that make sense? Okay. And then this is your x. Then your formula, you have a squared minus something squared. And the formula is a plus b, a minus b. And if you actually multiply a plus b times a minus b using float or the box, you will get the expression above in blue, dark blue. Okay, so my a value is x. Instead of writing a, we're writing x. And instead of writing b, we're going to be writing 10i. 10i. Okay, so then I fill in everything else. And then we just separate and solve. Set it equal to 0. So x is equal to negative 10i and positive 10i. Alright, number 29. We're going to solve this one by using the textbook method of difference of squares. And I'm going to add 225 to both sides. Remember, you cannot get 225x squared because they're not in like terms. It's like saying Pepsi plus Coke equals Pepsi. Like 2 Pepsis. That's not right. You can say 2 sodas, but you can't say 2 Pepsis. I'm wearing a Coke shirt. I like Coca-Cola. So x squared plus 225 equals 0. We've been changing this plus sign to minus minus. Why did I do that? We're trying to find something squared minus something squared because this is the formula. A squared minus b squared equals 0, and that'll turn into a plus b, a minus b. So I guess you can call it b squared equals negative 225. And you're going to take the square root of both sides. Try to make this clear, clear, clear. Every time you take the square root, you must have the plus or minus. B equals, that is negative 1 times 225, so that would become I, and the square root of 225 is 15. So although this is your answer, for this problem we're just taking the positive. You could take the negative, but so that means that becomes 15i. That one becomes x squared. So that means every a value is equal to x. every b value is going to be 15i. So I have x plus 15i and x minus 15i. Separate them, solve them, you're done. And that's our answer. All right, questions 30 to 32. I'm going to go ahead and use my method called the square root method. You could use the difference of squares if you want to, but I'm going to show you guys. It's going to go really fast. So subtract 4, x squared equals negative 4. And then I'm going to take the square root of both sides. This is going to be x equals, remember you have to have plus or minus when you do the square root of an equation. And then this will be negative 4. So that is negative 1 times 4. X equals plus or minus, square root of negative 1 is I, square root of 4 is 2. So this is the answer. So if you were doing this problem to kind of show that you're factoring, you can do this. Now, you'll notice that this is not the formula for difference of squares. This is the formula for factored form, or x-intercept form it's called. That's what we're kind of working on. And now I'm going to do that for each one. One's positive and one is negative, right? Because it has plus, it has minus. So that's my factored form. You can clean that up. And then you just do the same thing we just did. Separate it, set it equal to 0, and solve. Remember, that just means two solutions, right? It just means 2i, negative 2i. Okay, so that's using the square root method to kind of, the blue side is what you kind of need to show that you're using, quote unquote, the factored form. The left side is the square root method. Let's highlight that. This is just using the square root to find us the solutions, but over here in blue, this is showing the that you're kind of quote unquote showing your work for factored form or factoring. Okay, let's try 31. We're going to use my square root method, the strings method, solving this problem. Okay, this one, I wanted to say x squared equals, so I'm going to divide both sides by 36. So that's gone. So you're left with x squared equals negative 25 over 36. Okay, I'm going to take the square root of both sides. Remember, when you take the square root, you have to have plus or minus. So that becomes x. The reason why that works is there is like a invisible 2 right here. In some ways, this 2, and the radical sign are gone, so it's left with x. Okay, this one, I'm just going to break it up so you can see it. This is going to be the square root of negative 1. I didn't know this, so that's what I'm trying to show you guys. This is the square root of 25, pay attention, and the square root of 1 over square root of 36. And the reason why I chose to show you that is that all of them are under the square root, the negative, the 25, and the 36. So I have the square root of negative 1 is I. The square root of 25 is 5, which you'll notice is in the top of the fraction. And the square root of 36 is in the denominator. Square root of 1 is 1, so we just keep that up there. And the square root of 36 is 6, but it's in the denominator. So here is our answers. Let's go ahead and plug that into factored form. So if I was showing the work here on the right hand side, I would add 25 to both sides. Now I'm going to use the factored form. Come on, come on. Okay, so that's just using my solution, right? One positive and one negative. And you'll just clean it up. Separate it, set it equal to 0, and solve. Do you want to see that? Sure. So again, the blue side, I'm trying to show you like what it would look like if you're showing kind of like I'm factoring this to solve. But we use the left side using the square root method to kind of show you how I got positive and negative 5i over 6. Then you would just subtract both sides and get x equals negative 5i over 6. Ta-da! Okay, number 32. Again, we're kind of showing you using the square root method. And then the square root method gets our solutions, and we use the solutions to go back to factor form. Or you can use the difference of squares formula. So I'm going to divide by 64 to isolate. So that equals 1. So you're left with x squared equals negative 49 over 64. I'm going to take the square root of both sides. When you take the square root of both sides, you must have a plus or minus. So you're left with just x. And everything is in the square root. So remember, this is a square root of negative 1. So that is I. The square root of 49 is 7, which is the numerator or top of the fraction. And 64, square root of 64 is 8, but the 8 is in the denominator. So these are my solutions. And I'm going to use that to put it back into factored form. So let's work with orange. So again, if you were showing others how to factor, most people are not going to ask you, how did you get these binomials that we're working towards? They just kind of want to know what goes in these binomials. And remember here, when I'm doing this, this is not the difference of squares formula. This is the factored form, which is the whole lesson. So let's put here in this white box, I have positive 7i over 8 and negative 7i over 8. Let's go ahead and clean this up. Wow. Eraser. Notice my fractions are running up and down, not sideways. And then you just set them equal to 0. Zero product rule. And solve, and you'll basically have what we had previously, right? Positive 7i over 8 and negative 7i over 8. Okay, so the work on the orange is showing you that it's looking like to others that you factored, if that makes sense. And that was, remember, you don't have to do the end of these, just optional, or I don't know, you want to challenge yourself. So that was lesson 1.4, solving quadratic equations by factoring. We can check your, we didn't check our answers for those bottom ones. let me check one. Let's just do this one. 64 times 7i over 8 squared, does that equal negative 49? And 64 over 1, 7 squared is 49, I squared is negative 1. And this is 64. So 64 divided by 64 is 1, so you multiply that as negative 49. And if you chose to use negative 7i, it's saving image, I don't know if you can see that. Negative 7 times negative 7 is 49, I squared is negative 1, and then 8 squared on the denominator is 64, and then you can just cancel, negative 49 equals negative 49. So I didn't do checking for all, don't not. Please save it, I'll be upset. Just didn't save the last part, but hopefully that was helpful. We'll see you guys later. Bye.
In the class of 2010 of trigonometric, Mr. Ing, we learn about quadrant first to the fourth. Oh wait, that's algebra 1 stuff. We learn about trigonometry in this class with who? With Mr. Ing.